Okay, last lesson here of Unit 4. Yay. So this one's a really important lesson because it shows up every year on the exam and you do a lot with it. So graphing linear inequalities is what we're doing today. Inequalities, as you might remember from previous lessons, have an infinite number of solutions, and that's what makes them super unique. Inequalities have an infinite number of solutions. That's what makes them unique compared to equations. To graph a linear equality means to plot, or in our case, or, let's not say or, to shade all of the points x comma y that make that inequality true. So that means that there's an infinite number of points that you would need to plot in order to make the inequality true, which is kind of impossible to plot an infinite number of points. So we're going to look at how we're going to do that. Okay, so this is just like graphing lines with your slope and your y-intercept. You still need to be solving for y. You are still using the slope and the y-intercept to plot those points on your graph. The only difference here is that instead of having something like y equals mx plus b, you might have y is less than or equal to mx plus b. And naturally that inequality can change to be greater than or equal to, just greater than or just less than. So there are two, just kidding, before we jump to that, I'm missing this sentence here. This one's an important thing because we tend to forget this a little bit more often than we should. Make sure you are remembering to flip that inequality whenever you multiply or divide by a negative number. And so again, when I say flip that inequality, I mean if you have, change the direction of it. Change the direction is basically what I mean. So if you have less than, it would change to greater than. You're not changing if it has an or equal to or not. Okay, so because inequalities aren't the same thing as equations, there are two new things that you need to be on the lookout for when you do graph inequalities. That's two new things that make them different from the graphing equations. And one of those new things, well, we'll go over both of them. Those two new things are shading. I don't know if shading has two Ds. Shading, I don't know. Are shading, and you need to consider a dashed versus a solid line. And we'll talk about those two things next. The dashed versus the solid line really have to do with the open and closed circles if we're talking about like our old school number line graphs. So if we take a look at our inequalities, we have our less than and greater than, and then our less than or equal to and greater than or equal to. So just like these less thans get the open circles and the or equal tos get the filled in circles, the just greater than or equal to, just greater than or less than are going to get dashed lines. Dashed or dotted lines. Meaning that when you draw those lines, it's going to look something along the lines of, say lines one more time. Oh my goodness. My hand keeps, help. Okay. Something along the line of that. You know, it's going to be a dashed, not a solid straight line. And because it's dashed, because what that open circle means, that is just simply telling us that points on a dashed line I haven't had breakfast yet this morning, which is why my brain's not functioning. Points on a dashed line are, keyword here, not included in the solution. And this is something that's important because they always ask about this. Okay, so then on the flip side, the or equal to's are going to get solid lines, just like normal. They're going to get something that looks like that. And just like on the flip side of that, with a solid line, with a closed circle, a point on the line is a solution. So when you're dealing with a solid line, I can write that over here actually in black, a point on a solid line is included in the solution set. We call the solution a solution set because there's an infinite number of them. So it's a whole set of them. It's not just one number. It's, all of the numbers that are greater than or equal to blah, blah, blah. Okay. The last thing that we need to throw up in here, is how to shade. And I'm just going to move this kind of out of the way a little bit. The shading. Let's go purple for shading. When we're talking about the shading, you're going to shade based on what the inequality says when you read it. So that will make more sense when we look at some examples. But if you're dealing with a less than or equal to, you would be shading where the points in the numbers are getting less than or equal to that point, which would kind of be below, making sense. All right, that was a pretty long intro video. The example should be a little quicker.